Welcome to this month's EMBL ABR webinar. It will be about the new opportunities for clinical bioinformatics in Genovic, the Melbourne Genomics Health Alliance shared clinical system for genomics. My name's Christina Hall and I'm from Melbourne Bioinformatics, which is a node of EMBL ABR, and I'm your host for today. My colleague Susanna Bacon from ARDC is in the background hosting the webinar for us. To start, EMBL ABR is a distributed national research infrastructure network providing bioinformatics support to life sciences researchers in Australia. It was set up as a collaboration with EMBL ABI to maximise Australia's bioinformatics capability. There's 13 nodes currently across Australia, and each of those undertake or support bioinformatics research around several key areas: data, tools, compute, training, standards and platforms. Before continuing today, I'd like to mention a couple of housekeeping items. We'll mute all attendees' microphones during the presentation to minimise the background noise. And if you have a question, please type it into the question box and we'll look at the questions at the end of the presentation and relay them to Natalie. The broadcast will be recorded and made available via the EMBL ABR YouTube channel, and we'll let you know by email when that's available. But today we're very happy to have Dr. Natalie Thorne speaking with us. Natalie is the lead specialist in clinical genomics with the Melbourne Genomics Health Alliance and co-lead of the data sharing program within the Australian Genomics Health Alliance. Natalie has more than a decade of experience in bioinformatics with a PhD from the Walter and Eliza Hall Institute and 5 years postdoctoral experience with the University of Cambridge Cancer Research Institute. Natalie's interest shifted towards translational projects involving the implementation of bioinformatic approaches into the diagnostic setting. And this led to her foundational role in clinical bioinformatics within the Melbourne Genomics Health Alliance in late 2013. Natalie's now providing strategic leadership in the implementation of clinical genomics at a state, national and international level. In this webinar today, we're pleased that Natalie will share her experiences and observations on the changing landscape of translating research bioinformatics into the health system innovations. So over to Natalie.
Thank you. Look, thank you very much for this opportunity to speak with you today. It's been quite a journey over the last 5 years to get Genovic in place, and I am really looking forward to sharing with you a little bit about what I've learned about how to innovate in clinical systems. So 5 years ago, several members from Parkville got together, medical institutions got together after years of talk and no traction, and the members put their money on the table to form the Melbourne Genomics Health Alliance. 2 years later, in 2015, the state government funded $25 million for a 4-year program of work, and a further 3 members came on board. So at the time when the alliance formed, we could see there were several barriers to genomics. There were no funding models for reimbursement. There was a lack of evidence for actually the effectiveness of genomics, even though everyone said, you know, we know genomics is going to be a good thing. There are several legal, ethical and social issues that really needed to start being addressed. We had a workforce that, although might have been aware of genomics, was really not ready for genomics in practice, and really no infrastructure to manage and share genomic information. There was very limited activity in clinical genomics. People didn't have the tools they needed, and there was a risk of duplication of effort and siloing of data. So what we needed was widespread change, and we set up clinical systems, flagships, so that we could actually design how the clinical services needed to be delivered. We launched a range of workforce development projects, and we started on the path to putting in place a shared clinical grade system. We conducted 16 flagships over the course of 4 to 5 years. These range from pediatric to adult, germline and somatic, pathogen genomics as well, singletons, testing individuals, as well as testing trios with mum, dad, and a child. Whole exome sequencing mostly. We also piloted some rapid testing. So a total of 375 patients have been tested, and all but one of those tests has had a report completed. So we have a lot of projects underway at the moment, over 90 projects, most of which have been completed. The projects are really leveraging the real-world testing of the flagships. So I lead the innovation and adoption stream, which works hand in hand with the data and technology team, and that is the team that has delivered Genovic. And that's what you're going to hear about today. You're going to hear about the intersection between the technical systems and the data, and the processes of innovating in the healthcare system. So, what is Genovic? It was launched 2 months ago. It's very exciting. It's a result of 5 years of extensive work by Alliance members, working closely with over 80 individual people within the Alliance. We set out to implement a system with a very specific overarching aim: to minimise the cost and waste in delivery of genomic testing in Victoria, improve patient care, and accelerate translation from research. And obviously the last point is what we're going to be talking about today. So Genovic supports the integration of genomic medicine into clinical care. It enables diagnostic laboratories with a common platform for bioinformatic analysis as well as variant interpretation, the part where once we've detected all the variants, the diagnostic scientists have to figure out which of those variants are important for the patient's care. So it facilitates controlled access to data for research, and that's something that we're still currently implementing. We knew that homegrown tools were not going to evolve and scale to the growing and changing needs of genomics. And we knew that the majority of IT projects are very hard to achieve, that often don't succeed, particularly big, complex projects like this. Certainly governments and our Alliance members, rightly so, are very wary of them. So I'm going to give a brief look at the journey that we took to getting Genovic in place, really so that you can get a sense of what it takes to go from a concept of, yeah, we can do genomic testing, to actually having genomic testing working in the healthcare system. And then I'm going to start spending some time on unpacking the differences between research, discovery, and the healthcare system world. So 5 years ago, when I made the transition from research into this clinical world, I was doing all the usual research bioinformatics stuff that I presume most of you are doing. And I shifted to a role of working within my own collaborative teams to a role of working across 10 Alliance members, hospitals, laboratories, medical research institutes, and working closely with the software development team. To say that I was underprepared would probably be an understatement. But within the model of Melbourne Genomics, I've gotten there. This model of being highly collaborative, focused on being facilitative, embedded within the members, our stakeholders, and working with highly multidisciplinary teams. So I started out, really, my role was started out working on the development of our early prototype systems. These systems that would eventually allow us to design and deliver Genovic. And really, what it felt like in the beginning was literally laying the tracks as we went along, building what we needed just in time. To be honest, this is what it feels like even now when we're prototyping something, even in the systems that we have already. So in the early stages of innovating, in the early stages of taking what you've already discovered and trying to make it work, this is what it feels like. I guess research can feel a bit like that when you're starting out and you're sort of going a little bit blind, you don't know which way you're going. But in the clinical world, there's more disciplines involved. There's more different sets of people involved, and more processes and moving parts. So that's how it feels a little bit different. These prototype systems that we built focused on two key areas: the bioinformatics pipeline and the variant interpretation tool. So I really want to emphasize the importance of prototyping. Prototyping helps with building collaboration, capability, and buy-in. So in terms of collaboration, the importance of this is that multiple people get to share their experiences. They get to test out what they imagined versus what they realized they actually need and what's really important. They get to try out new ideas without worrying about how this has to be the final product. And in terms of capability, laboratory diagnostic scientists and clinicians get to work with software developers and learn about software development practices and all of those important things. And the software developers get to learn from the users. They get to really understand how to work with the people that they're helping to deliver the systems for. And it helps get buy-in. So all the ideas and assumptions gets tested and refined, and everyone starts to get a real awareness of what the costs are and how much it actually takes to deliver the software and systems that are needed. Underpinning all of that is that we get to create teams and networks of experts across the institutions and disciplines, and this is what enables us to actually innovate. So as I said, it's been a 5-year process from prototyping to building or delivering this clinical system. Multiple steps in that prototyping that allows us to assess what our future needs and define our requirements. Going through a shortlisting process of looking to vendors, commercially supported products and services. Piloting to help us decide and select which of those vendors and services are going to suit us best. Going through contracting and tender processes, entering into collaborations with various vendors and service providers, and then ultimately planning and executing an implementation process. It's been a very long, complex process, but there's been lots that we've learned along the way that helps us understand how we're going to innovate in Genovic going forward. So just to put into context, what do we mean by implementation innovation, and where does Melbourne Genomics sit on the spectrum? You've probably heard of Australian Genomics. That sits more at the translational research end, possibly where you sit as a bioinformatics researcher is more at the discovery research end. And so what we're really talking about is how do we move from discovery through to translating what you have, getting it ready for implementation, and then somewhere in the future, hopefully, into routine practice. So let's think a little bit about this distinction between research and clinical bioinformatics. Some of you might have seen this slide before. In the research world, using this metaphor of the planes, you could think of yourself as being the fighter jets. You guys are coming up with something bespoke and surprising, something original. You're inventing things. And then once you've got a bit of evidence that suggests that what you're doing might actually be useful in practice, and once what you're doing is well known enough and has reached a certain level of maturity, we can start to work on translating that into the clinical system, where we now need things to be standardized, routine, an enterprise level system where we carefully manage how we change things. Because we have people using this in clinical care, we can't just change things willy-nilly. So we're not really just like Qantas. We also, it's not just a standard airline system, if you like. We also like to think of there being innovation within a standardized routine system. And that's what I'm trying to allude to at the moment. So we think a bit more about this distinction between research and the clinical world. The researcher might take months or years to work on a particular innovation, optimizing and exploring a discovery that they're working on. A clinician needs something that's going to work within minutes or in a much smaller time frame, And the main focus is avoiding some sort of serious area. Obviously, you want to, as a clinician, find something that's going to be useful for the patient, but ultimately you don't want to do anything wrong. So if we go from discovery to innovation, the researcher who makes the discoveries, it's not as simple as saying, oh, my method will help diagnose more bowel cancer patients, so let's just now do this in practice. You need more than doing it, and you need more than just getting the evidence that it works. It has to actually be used. In other words, it has to be adopted. So what we're trying to do here is take our discoveries and get them mature enough so they can be translated, that we can gather evidence to say that this should be something we implement. We implement it and then actually show and overcome all the various hurdles that allow diagnostic scientists and clinicians to actually adopt or use it. So think about innovation as being the changes that allow a product or a service to get significantly closer towards being used in practice. So in the normal realms of the healthcare system, getting to adoption. So this is what we would see as innovation as opposed to discovery. So here's a clinical implementation scenario from bioinformatics research. Say a researcher comes to me and says, oh, I've developed a bioinformatic method. It can detect a new resistant pathogen. It's based on a new handheld sequencing technology. And we've already shown it in some patients, so this is something that we can use in the clinic. So my question automatically is things like this. Which laboratory will collect the sample? So you've got a method that will detect that pathogen, but who's actually going to do this? Has this technology ever been accredited before? How rapidly is the technology changing? So are we going to implement something and then the technology moves on again in a couple of months' time and then we have to change everything? Does the laboratory that you're thinking who might do this test actually have the capability to take that bioinformatics that you have done and understand it as well as you have to be able to implement that? How's this test going to be ordered? Which system? What information is going to be required so that when they order the test, someone is going to know what they're looking for and how to report on that? Who will actually do that reporting, the interpretation of the results? How much is the test going to cost? How is it going to be funded? What might the throughput be? Is this a test that we're going to do every week, or do we need a system that needs to do several of these per day? Is there a solid or established QC for this data, or is this QC that only you really know about because you're used to just flicking through a few different kinds of graphs on the data, but it would require quite a bit of work for someone else to understand how to do that same QC in a routine way? What is this report going to look like? Have you tested it out with clinicians? What is the information that they need to make decisions? And are there guidelines for this? Other than researchers and the clinicians that you've been involved in, would other clinicians understand the limitations and the uses of these tests? So if we pull all of this together, thinking about that scenario and all the types of questions that you need to think about when you implement something, here's an implementation framework. So you need to start by thinking about my bioinformatic method or my new technology that I've been looking at. How mature is it? Is it stable yet? Is it portable? Could I take it out of the system or from my laptop or from the server that I've been working on it? Are there many dependencies, and how easy is it going to be able to set that up? Have I really thought about what the needs are for this and the benefits that are going to be there for the health system? If you've had some thoughts about that and you've made sure that it's mature enough, then you can start the process of translation. This is when you start understanding the business process. Like I said before, who's going to order the test, how are you going to order that, who reports, all of that kind of thing. What are the use cases? Who are the people that are going to be using this, and how are they going to be interacting with your method? What are the different technology choices? Would this be something that's online? Is it done in the background? Is it supposed to be handheld? Is it going to be implemented with your Python code, or does it need to be done in some other way? What scope is there going to be, and what resources do I have available to me to start doing this translation? And then, of course, you would start actually prototyping something, getting a minimum viable product that diagnostic people and clinicians can actually get their hands on and try. Doing this allows you to understand better what the requirements are, really prioritize what you think the features need to be, start getting user feedback, really identifying what the costs and benefits are going to be and what the timeframes are for this. Is it actually the right time to implement this, or should we wait another 6 months till something else is done first and then this will be easier to do? The next step would then be the actual implementation. Once you've had a successful prototype and everyone agrees, you've got some funding, you've identified most of the key barriers, then you're really working at refining a product, making sure you can integrate it. Instead of some of the manual steps you had in there, you start to eliminate some of those, move more towards integration and automation, making sure the laboratories can get this accredited, that it's supported, that someone is there and available to help when things go wrong, that your method or service can be maintained over time, that you have funding to do that maintenance, and that you start to have a bit of a formal process around managing the roadmap and how this will be managed into the future. Underpinning all of that is making sure that you engage the stakeholders. These are the users, the laboratory people, the hospitals that may or may not fund or order these tests, the patients who might be benefiting from these tests, the clinicians, the government. You need to be also managing how you implement this change and being transparent in the way that this happens so that everyone's on board and make sure that this is smooth as possible. So really there's a lot to consider when thinking about translating your research into new ideas or new ideas into something that actually gets used in practice. Lots of steps, lots of technical aspects that you probably already thought about, business aspects, diagnostic and clinical aspects, legal and ethical aspects and governance aspects. Luckily, Melbourne Genomics is experienced in facilitating this. And we have already had a lot of experience bringing together the different roles or the different disciplines that are required to do this. So you don't need to be an expert in all of these things, but you need to be aware that in trying to translate your research, that these are the kinds of skills that you need to be able to work with and access. So particularly the three big domains that I see are emerging as very important are clinical bioinformatics as well as health informatics, so understanding how to navigate the systems world in the health system world, and pathology informatics. The part that glues them together really is then the business management aspects, governance aspects, and the systems development, the software people. So what Melbourne Genomics has done is we've done all the messy work. We've done all that stuff that takes ages behind the scenes, all of that stuff where it looks like you're not making any progress for a long time and then all of a sudden the house is built. It's culminated in 5 years of working closely with over 80 of our Alliance members. We drew up the plans after doing all that prototyping. We laid the foundations. We contracted a significant amount of work, put in some smart technology, and now we have this house. It's a complete system. We're at lock-up stage, but the landscaping hasn't been done yet. We've got a spot for the fridge, but there's no fridge there yet. There's things that we haven't thought of yet that will be needed. Like any new house, we've got to live in it for a little while before it feels like home and before you can start enhancing it. So consider this webinar a geek's version of the housewarming party. So it's not like you can just go out there and find a whole lot of other Genovics. This Genovic system is actually quite unique. What we've delivered is highly modular. It's a modern build in the cloud, and we're pulling together a detailed manual over the coming months. So let's take a little closer look at Genovic. Genovic enables an end-to-end workflow for laboratories, and they do this, they access Genovic via several FHIR-based APIs. Now, FHIR is the emerging standard in health informatics, in the health system, for sending messages in the health system. So the labs only have to integrate to these 6 or so FHIR-based APIs. The central to Genovic is GOS. It's our genome orchestration service. It takes care of the rest. It essentially does our integration. So it essentially orchestrates from test order to data storage, then the pipeline analysis of the genomic data, and into the interpretation tool that here we've got ELISA interpret for the interpretation of our variants, and DNA Nexus is implemented for the pipeline platform. Then the labs are alerted to the fact that the data has arrived in ELISA, and they can log in and start doing their diagnostic variant interpretation work. Once they've completed that, a report is generated by ELISA and sent back via the FHIR APIs, via GOS, to the laboratory information systems, where they can execute the final part of their reporting. So Genovic uses serverless architecture so that we only pay for what we use. It's robust and fast. It utilises, as I said, the AWS API gateway services, S3 and Glacier storage. We've conducted our own penetration testing and security testing and passed with flying colours. And we're currently investigating and prototyping a solution that will enable controlled access and research use of the data. So a solution that is now built with Genovic in mind rather than the existing solution we have for access to data, which was not built with Genovic in mind. So really the take-home message here about Genovic is it's modular, it's robust, it's secure, and it's a scalable system. It's a cloud system. It includes best-in-breed supported vendor products and services, and it's going to allow Alliance members to easily integrate new tools as genomics needs evolves. What I'm hoping and what we're aiming for is that Genovic will also enhance the way researchers can interact with it and accelerate the way that you can translate your research discoveries into something that's actually used. So some of the further key benefits of Genovic are that it enables this clinical and research genomics. It lowers the barrier to entry into genomics for people coming in. So there's more redundancy, more opportunities for sharing. I'm sure we haven't even begun to think about the ways that we might want to be sharing data and the ways we might not be wanting to share data within Genovic and potentially out of Genovic to national systems. It gives us an ability to compare, potentially for example, for QC purposes. And it reduces the burden of data sharing for clinical labs. You currently have to manage that. It reduces costs through reduction of duplication of effort, so you don't have to store the data in different places. You don't have to have the skills of this kind of computing and systems in multiple places, and you don't have to have multiple infrastructure. There's a dedicated support team for this, and most importantly, despite all of that, the user still stays in control. So just briefly to talk a little bit more about GOS, this genome orchestration service or our integration layer. This is what enables the modularization and the standardization. This is what is crucial for us to keep up with this rapidly evolving field. So yes, we need a system that's in lockup, that's stable, but it needs to be able to allow us to be agile. It is what enables the collaboration and the automation. It saves us time and improves the quality of what we do. It allows us the quality control, redundancy, and the scalability, so we can identify issues really early. We can easily expand and add new services, swap in new things into Genovic, and it allows us to manage the requests for change, because yes, that is going to be the next challenge, is how do we evolve and grow and modify and improve Genovic as the needs of our members evolve too. It is what allows Genovic to be sustainable and gives us the power in many users that allows us to continue with Genovic. We looked at commercial solutions for integration, and really they were not suitable. And so what we've come up with is this very specific genomic solution that caters for the fact that we have complex messaging in genomic testing and large data that we're dealing with. So it's a custom solution for Genovic. It's based on a lot of Python and open source libraries, no extra technology. It's perfect for this business logic, this complex business logic and the high volumes of data. It's easy to scale and add new components, uses RESTful APIs, no software costs, and it's very, at the moment we're using quite a light version of this FHIR-based standard for health informatics. So I'm just going to go through a couple of key aspects of Genovic where I want to illustrate the types of innovation that we're doing in Genovic. So the first is going to be about the tool, the ELISA tool that we have implemented in Genovic to cater for the interpretation needs of our diagnostic laboratories. And the second is something that we're working on, which is around pipeline research to cater better for researchers' needs inside Genovic. So firstly to ELISA. So we implemented ELISA in quite a unique way. So what we've done is we've leveraged some of the sharing capabilities that have been built into ELISA but haven't actually been used by most users of the ELISA system from Agilent. So because Genovic has this cloud hardware as the basis for it, they share that hardware. Users share the annotation information that, or annotation server and particular data sets that they can share. But each of the members have their own instance of ELISA. This is deployed, as I said, all within the AWS cloud. And they have a shared portal for this and a shared connector, or the APIs that connect them via gauze. So this is not for you to read, but I'm really just picking out a few keywords here. But we partnered with Agilent, the Agilent ELISA team, and implemented a whole host of new features that took over a year to design and specify, implement, and then test and actually implement. Things like permissions management, how to attach QC files, customizing things and configuring things, giving access to previously curated variants, being able to copy information from one variant to the next time you see a variance between different laboratories, audit trails and APIs, things that you would think you wouldn't think of as being innovations, but things that are incredibly important for those who actually do this innovation. They're very specific improvements that directly improve efficiency and accuracy. But you need to be an expert or working with the experts, working with diagnostic laboratories to actually identify these. These are innovations, but they're not the kind of innovations that you're thinking about, right? So where does this leave you, the bioinformatics researcher? I think with Genovic in place now, this is just the beginning. This is where exciting things can now happen. There's so much to be done. We've provided the building and the wiring, but many of the rooms are still empty. And this is now where we can start to innovate. Which brings me to the next part that I wanted to talk about, is about portable pipelines. This is something that we're working on within the Alliance to help support researchers utilise Genovic and system that we've built in Genovic, but bring their pipeline research closer to the Genovic world. So it's I'm probably preaching to the converted here, but it's no longer enough for bioinformatics workflows to run on your HPC or your on-premise hardware. They also need to be running in the cloud. Cloud is often cheaper, it's less the work than maintaining your own HPC, your own cluster, and it can scale to arbitrarily large data sets. Pipelines can be run on multiple cloud and HPC systems, but pipelines that run on multiple ones are called portable. So here's some examples: the Common Workflow Language, CWL, and WDL, Nextflow. You've probably heard of all of these. So in Melbourne Genomics, we've been facilitating the development of portable pipelines. We are currently working with the WDL language and the Cromwell engine. And we're not saying that these are the best ones, but these are the ones that we have chosen to work with, particularly for this year, as a way of getting something set up to help support researchers and laboratories to work more closely together, so that there's a greater chance of translation and exchange of research methods into the laboratories. So by working with WDL and the Cromwell engine, we have the opportunity to implement pipelines that can run on the Google Cloud, on AWS, as well as on HPC computing. And we can also have those pipelines be executable inside DNA Nexus. So how do we get Genovic ready? I see this as the evolution of clinical bioinformatics. We need to be, as a bioinformatics and clinical bioinformatics field, embracing best practice and cloud computing. So what does this mean? We need to be utilizing serverless architecture, changing the way that we think about the way that we build our bioinformatic methods. The data will be stored in the cloud next to the compute. We need to understand the business process and design bioinformatic methods for potential integration into Genovic. We need to develop portable pipelines for the cloud. So you could start doing this using the APIs in Genovic and build on Genovic genomic data models. We need to be thinking more carefully about test suites that we can develop and using continuous integration much earlier in the development of bioinformatics methods. Deploying in the cloud, using infrastructure as code. This is really good for clinical use because it ensures much more consistency in the way the methods are implemented and executed. We need to think about using separate environments and setting up separate environments as a more routine thing that we do. Development, testing, staging, as well as production environments. And then I guess the other part is recognizing that the hard part on top of all of that is really the soft skills. So collaboration, as distinct from cooperating and coordinating our efforts, collaborating and actually working in real time together on things so that we're having that shared experience of iterating and refining our ideas and experiencing what we see are the real barriers and needs and facilitators. Change management, this process of really understanding what the barriers and enablers are in people. So lots of conversations with people, in processes, the different steps and between people and systems. And then lastly, stakeholder engagement, the part which is really understanding our users, the funders, the regulators, and our patients. So besides your computer, where you remind yourself that you've got to be writing papers and that you've got to write bioinformatic methods that are reproducible, and I know we've been talking about reproducible research for a long time, I'd like you to consider that there's a few other things you should be having on your Post-it notes near your computer. Making sure that you're thinking more about how to develop your bioinformatic methods from the get-go that are more easily testable, more maintainable, portable, interoperable, by making sure that you're utilizing standards and ontologies and APIs where possible, documenting, and then finally also making sure that you've started the process of thinking about or talking to the people you need to talk to about making sure that it's going to be useful in clinical practice and it's going to be cost effective. So what are some of the opportunities? I see that there's going to be opportunities, and really this is going to be shifting from month to month, year to year. But there are already opportunities for bioinformatics research and clinical bioinformatics research within Genovic in the areas related to quality control, how we use the large amounts of data that are going to be stored, and set up services and products that allow routine longitudinal analysis and excellent visualization. The setting up of reference sets that we can all use across the Alliance that standardises the way we do quality control and better allows us to make that consistent between laboratories. There's going to be opportunities to better support the laboratories in terms of truth data sets. We all know in A12878, there's lots of other truth sets out there, as well as that. There's various data from different laboratories and clinical groups around cancer. How do we bring all of that together, store that in a way, and have services associated with that data that better enables validation by laboratories? The new human genome is definitely something that we need to be shifting towards. So any research services methods that are going to accelerate the way that we can adopt the new human genome build is definitely going to be worthwhile. Of course, any methods you're developing, a new CNV method, better indel detection, detection of homozygosity runs, whatever in particular that may be, being able to write that into a portable workflow like WDL, implementing and deploying that in the cloud with some framework around testing and maintainability and deployment in environments that allow that testing, staging, and deployment would be really good. One of the things that we keep talking about is whole genome analysis, and that's something that some labs are starting to dabble in. So areas around that would also be useful. So there's going to be lots of opportunities, how you actually know about what's going to be useful to laboratories, and partly that's going to be what you think is of interest to you and what your research is. But in talking to diagnostic laboratories and clinical genetics services, you're going to get a much better idea of how your research might be translated into practice. So what next? If you're an Alliance member, you can get in touch with the Bioinformatics Working Group. You could read some of the technical documentation that's available on Genovic and currently being vastly expanded. You could get some experience working in a diagnostic laboratory and starting to get a bit more of an idea of what that world is like. You could plan your next grant application with Genovic in mind. Collaborate with a diagnostic laboratory, or at least think about what some of the steps might be when you are considering how your methods might then go on to be translated and eventually implemented. You could connect more with people to help you in thinking about that translation journey towards implementation for your bioinformatics. And of course, you could start learning more, learning about AWS, API services, the FHIR standards, about WDL and other portable pipeline technologies and execution engines, some of the work that the Global Alliance is doing. You could start by making and sharing portable pipelines and becoming involved in the work of the Bioinformatics Working Group. If you're really interested in getting into the clinical and diagnostic bioinformatics world, you could think about doing a short course and sitting an exam to become an accredited health informatician. After all, I think the world between clinical bioinformatics, health informatics, and pathology informatics are three disciplines or three different worlds that are going to increasingly become more and more important to work together into the future. So there are many things to think about when trying to innovate in the healthcare setting. There are many opportunities now that we have a system like Genovic in place, a unique system that no other states in Australia have in place and most places in the world don't have in place. So we do have a unique opportunity. Melbourne Genomics has enabled huge growth in our understanding and capability to innovate, to facilitate that journey from translation to implementation. We also have a lot of experience in bringing together the fields of bioinformatics and cloud computing with health and pathology informatics. So remember, this is just the beginning of new opportunities in clinical bioinformatics. It's a really exciting time, and the path from translation to implementation has actually never been clearer. Not to say that it's easy, but definitely has never been clearer. The Melbourne Genomics work has involved really hundreds of people, all the people involved in the flagships. Many governance groups, working groups have been involved. Some of you have probably been involved in this work. Thank you very much for your contribution if that is the case. Yeah, lots and lots of people involved. In particular, I'd like to thank the data and technology team and the members of the innovation adoption stream that I lead, who have been the ones working behind the scenes over the last year and a half, or year or two, in this real final stage of getting Genovic to the stage that it is now. So thank you very much. This has been a pleasure.
Well, thanks very much, Natalie, for inviting us to Genovic's housewarming party.
No worries.
It was a really wonderful talk, I thought, looking at the processes behind translating research bioinformatics into innovations in the clinical system. Really, really interesting. So thanks very much for that. We've got a couple of questions that have come in. First up, Nick Wong said a fantastic presentation, and he'd like to thank you very much. I'll start with the kind of more wide-reaching questions. Nick asked, how is the data managed, stored and shared on Genovic, and who owns the data?
Okay, so that is a great question. I'm just going to flip back through to the Genovic slide. Now, what I want you to remember is that I'm more the facilitator than the technical person. And probably, you know, as I said, this is the housewarming party. Probably what we really need now is some more further opportunities to get some technical details about how Genovic is built. But you can see here that the data is stored in Amazon S3. In particular, what we have to think about, other than storing it in S3 buckets, which and many of you are probably familiar with, but what we really need to think about, what I care about a lot, is the way that we model the storage of that data, or the data model for storing that genomic data. So what other information do we have to store with a FASTQ file about who did it, when it happened, how long can that data be stored for, and so forth. So there's kind of business rules, information, and so that all of the information that we need that will then allow us to orchestrate that data through the system, know when to move it and how to move it through the different services, but then also to understand how what are the restrictions that we have on sharing that data for different kinds of research use. So that's the part about storing of the data. Of course, there's also rules around how it then gets stored into Glacier after its immediate use, laboratory use. And then what was the other part of the question, Christina? Sorry, I couldn't hear you. You muted yourself. Yeah. Sorry again.
Sorry. So it was, how is the data managed, stored and shared, and who owns it?
Okay. So the data governance is really quite complicated, but I'll simplify it to say that the laboratories who do the test own the data from a governance legal perspective. When we share it, what we are doing is acknowledging that the laboratories have published, if you like, or shared the data with Melbourne Genomics, and then we become custodians of that data according to a data sharing agreement, And then as custodians, we have our own policies in place that dictate and determine how we then share that data. Of course, there's also HREC consent aspects to the sharing of that data, not just the fact that we've become custodians of that data from the laboratories who officially own it.
Great, thanks. We also have a couple of questions from Vicky Marshall. The question is, how can you buy in if you're not already a Health Alliance member? How to get involved?
So technically speaking, it's not good. It doesn't actually take too much to use Genovic. So the technology part is not the barrier. The buying in part is got a lot to do. It's not really buying in, but is really about contracts and services agreements that need to be set up. So are you going to become an Alliance member? Do you want your own instance? Those kinds of things. So that's something that we can work through depending on what your organisation is. But yeah, definitely interested in pursuing into the future ways that other people can use Genovic.
There's a question here too. Does it have to be ELISA? Can someone connect with VS Clinical from Golden Helix, for example?
Yeah, so this goes to the way that we've designed Genovic so that it can be flexible. So no, you don't have to use ELISA. Yes, it is technically possible to put in another variant interpretation system. So the question here would then be, who's going to do the work to integrate that new system with GOS and the FHIR APIs? So we would just need to work through how to fund that effort, yeah, because it's technically possible.
We've got a question from Mauro D'Amato. He suggests it's a great initiative, a great talk, thank you. And is there a database showcasing data type and participants that can be consulted similar to the UK Biobank as an example?
So I assume that what you mean is there a way that you can interface with Genovic to see what data is in there? The answer is at the moment, no, but yes, that is something that we're actively pursuing. So, you know, if you go back to the analogy of the house, yes, we've got the house built. No, we haven't put the fridge in yet. So, yes, there's definitely very key parts of the Genovic system that, that don't impede the way it functions from a diagnostic and clinical point of view, but we definitely know that are needed, and we're currently working on. So a catalogue, an interface to be able to see what the data is definitely something that we're working on, and obviously that is going to directly feed into the system or the solution that we're building for enabling access to data, because obviously you'd want to be able to see what data is in there before you decide that you might like to use that data for research.
All right, well, I think we might wind it up there. Thank you so much for your time today and the great talk you've given, Natalie. I'll just take back the screen sharing. There are a couple of other more technical questions in there, and I think what we'll do is put them to Natalie in writing and send them out to everyone who's registered to cover off those technical aspects as well.
Very happy to do so. Thank you.
Great, thanks very much.
Great.
So thanks everyone today for attending. The webinar has been recorded, and the slides and recording will be available soon. And as I said, we'll email you with the links and the answers to those technical questions. If you've got any suggestions for future webinars or topics, speakers, anything, just let us know. And just finally, with AMBL ABR would like to acknowledge funding from Bioplatforms Australia and the University of Melbourne, and the ARDC would like to acknowledge NCRIS funding. As the webinar closes today, there'll be a short survey. It'll only take you a minute, so we would love it if you would fill that in. Thanks again for today, and goodbye.